Hi everyone. What we're going to be looking at in this video is the graphs of polynomial functions, and specifically we're going to look at how you can graph a polynomial really quickly if you know the equation, and also if you know the graph, how to find out what the equation was. Now these are two things that we've already done with quadratics, so it's nothing new in a sense. It's very similar to what we've already done. But there's just a few little tricks that you need to know when you're dealing with like cubics and quartics as opposed to just plain old quadratics. So what we are going to start off by looking at is, let's look at this function here, okay? Y equals x take 3 as one factor multiplied by x plus 2 squared as another factor. Now we know that this is a cubic equation because it's a linear factor multiplied by a quadratic. And if we expanded all of this, we'd get an x cubed term. So we know that it's a cubic equation. Okay, the process for graphing this is really similar to what we did with quadratics. So first of all, we're going to find the x-intercepts. Second of all, we are going to find the y-intercept. Now, third of all, this is the only little tricky thing with polynomials, is we need to look at what happens at the x-intercept, okay? And then finally, we can sketch the graph, okay? So let's just have a look, first of all, at step 3 in particular, because this is kind of interesting. So there's a few different possibilities when you look at each factor in the equation. I'm just going to draw a line here because this isn't specific to the equation that we're looking at here. And I want you to make sure you write this down in your book. So there's 3 possibilities for the factors. The first possibility is that we've got something like x take alpha. Now, if we've got that, when we draw the graph, we know that it's going to intercept the x-axis at x equals alpha, and the graph is just going to go straight through at that point. I haven't drawn it perfectly, but essentially straight through. Or alternatively, you know, depending on which way the graph is traveling, it may go down through like this as well. But we know that a factor like that will just cut through the x-axis, so we say that it cuts. Okay, second possibility is that we've got x take alpha all squared. Well, in this case, we know from quadratics as well that if we were drawing a graph of that, it's not going to cut through, it's only going to just touch the x-axis. So it's going to come down, touch the x-axis at x equals alpha, and then go back up again. Or alternatively, it could just come up from the bottom and touch. I'll just draw that in a dotted line. So what we say there is that it touches the x-axis. Now, this is where we're going to add in something a bit new. If we've got x take alpha cubed, then when we graph this, what it's actually going to do is something that we call an inflection. So it's going to come down, flatten out, and then keep going, but the curve is going to switch the way that it's curving. So this is curving down and flattening out horizontally. This starts off horizontal and then starts to curve more towards the vertical. Alternatively, the graph could be coming up from the bottom and it would do the reverse of that. Now we actually have a word for this. we call that an inflection. Okay, now you might have seen those in year 10, and it's just basically another possibility for when you have one of these factors with an x-intercept at alpha. Okay, so let's go back to our example. So I'm going to come back to our example up here. Y equals x take 3 in brackets times x plus 2 squared. All right, first of all, the x-intercepts, I know that they are going to be x equals 3 and x equals negative 2, because those numbers, if I put them into these brackets, would make the whole thing 0. The y-intercept, same as we have always done, occurs when x equals 0. So I'm just going to plug that straight into the equation, and I get 0 take 3 multiplied by 0 plus 2 squared, which is negative 3 times 2 squared, and that'll be negative 3 times 4, which is negative 12. Now, let's have a look at the graph. Should be able to fit it in over here. Just have to draw this carefully. You'll have a bit more room in your book. Now, I'm not really going to draw this to scale, but that doesn't matter. So down here is negative 12. That's my y-intercept. I've got an x-intercept over here at x equals 3, and another x-intercept at x equals negative 2. All right. What do I know? Well, I know that at x equals 3, we're going to cut through the x-axis. So I know that it's got to cut through here and go down to this y-intercept at y equals negative 12. So I'm just going to draw that part of the equation to start with. Then I know that at x equals negative 2, this is a squared factor, so it's just going to touch and then change direction. So I'm going to draw the rest of it in, touching at negative 2 and then going back down. Now, I'm sure I haven't drawn this perfectly because I've actually sort of implied that the vertex is here, but I've gotten the general shape right. For what we're doing, you don't need to get the vertex spot on, and in fact, because negative 3 is a bit further over, the vertex would realistically, it would be down here and we'd come up through like that. Okay, but the key thing is to get the x-intercepts and the y-intercept right, and the behavior at the 2 or 3 x-intercepts correct. Okay, I'm just going to do another quick example. So in this example, I'm going to say that y equals, let's erase that. Y equals 2 multiplied by x take 1 all cubed. So now I know my x-intercept is just going to be 1, and my y-intercept, there's only one factor there, it's just a cubed factor, that occurs when x equals 0 and y equals 2 times 0 take 1 cubed, which is 2 times negative 1 cubed. Now, negative 1 cubed is actually negative 1, because it's a negative times a negative, which makes a positive, times a negative again, which makes it a negative. So that's negative 2. And if I graph that over here, I'm going to say, here's 1, here is negative 2. And so my graph, I know that at 1, there's going to be an inflection point, but I know it's also going to be coming up through negative 2 here. So I'm going to be coming up, and it's a bit hard drawing this on a tablet. It's going to have an inflection point and then keep going from there. Okay, and actually, I should have done this before. I should be drawing arrows on each end to show that the graph continues. Okay, so same process here. I found the x-intercept, found the y-intercept, and then I've basically joined the dots, taking into account the fact that at my x-intercept, I've got an inflection because it's a cubed. Okay, so that's why I did the inflection. Okay, so what we've just looked at is if you know the equation in factorized form and you want to graph it. Now I just want to quickly look at if you have the graph already and you want to figure out the equation. And this process is pretty much identical to what we did with quadratics. So first of all, we're going to use x-intercepts to find factors. We're going to have a coefficient of a, and you'll remember what that is when I show you. And then I'm going to substitute a known point and solve for a. All right, so I am going to draw a graph and show you what I mean by all of this. And you'll have to excuse me if this isn't perfect, but I'm sure you'll be able to draw a much better version in your book. So here we've got a graph. It's cutting the x-axis at -2. There is a y-intercept of -9. Another x-intercept at 3, and another one at 5. So I'm going to come down through 2, come through that y-intercept. I'm going to come back up and touch at 3, and then go back up and through 5. Okay, so what we know is that it has to look something like this. Y equals a, and that's my coefficient, times x plus 2, that's my first x-intercept, times x take 3 squared, because it touches, times x take 5. Now all I have to do is figure out what a is by substituting a known point, which is my y-intercept. So I'm going to substitute 0, -9. So that means that I'm going to write -9 instead of y, times a, 0 plus 2, 0 take 3 squared, 0 take 5. So -9 equals a times 2. -3 squared is 9 times -5. And if I multiply all of those out, I get -9 equals -9t times a. So therefore, a is -9 divided by -9t. I'm going to use a fraction since I'm a mathematician. So a equals 1/10. And I'm going to chuck that back into my equation. So y equals 1/10 multiplied by x plus 2, x take 3 squared, x take 5. And that's all there is to it. It's exactly the same as the process that we used for finding quadratics. All we've done here is we've taken into account the fact that it touches, we've got more factors, and in fact this is actually a quartic equation. But this process can also be used for cubics and for quadratics as well. Okay, that's it. Thanks for watching.